Alright, so today we're going to be looking at statics. So statics itself is the study of forces and their effects on a system in a state of rest or uniform motion. So we're looking at some bridges, we're looking at just piles of stuff on top of each other, the scaffolding, and some light structures, where we're looking for kind of an equilibrium, so therefore nothing falls apart and everything is nice, fluid motion. So we're looking at the different principles. Newton's first law of motion. An object in a state of rest or uniform motion will continue in that motion till it's acted upon by another force. Second law of motion. The acceleration of an object is proportional to the net force acting on the object and inversely proportional to the object's mass. Or, just the formula, force equals mass times acceleration. And then the third law of motion, for every action force, there's an equal and opposite reaction force. So what are we looking for? We're really looking for the equilibrium, where something is kind of at rest or just in flow in one constant direction. If not, things can crumble and things can fall apart. And as we're looking at like a structural engineer, we want everything to be balanced, everything to be sturdy, and to stay where it is. So in order to get that equilibrium, we want a couple different formulas. Sum of all the force in the x direction to be equal to 0. Sum of all the forces in the y direction equal to 0. Those two formulas are going to carry us forward as we start looking at trusses. We want a bridge to stand, not to fall apart. We're also going to look at rotational equilibrium, which is then the moments. So we've talked about moments. We're going to look at moments more in depth here in this section. Moment is equal to the distance times the force. So these blocks right here are trying to move this guy clockwise. There's a distance from the fulcrum. This red ball is trying to rotate everything counterclockwise. There's a distance and the force that's being applied to that. When these two moments of these two sides are equal, then that teeter-totter stays balanced. So what we're going to start looking at is kind of vectors. So the vectors have two different types of things. They have scalar quantities. So it gives you magnitude, like your mass, your length, your time, your volume, your temperature, pressure, and speed. They just have one number, just the magnitude, how long it is. And then we have vector qualities, which is magnitude and direction. So position, like on the x, y plane, you got to go over x, up y. Velocity is in a direction. The force is being applied in direction, and the moment in those different directions. So we're going to start looking at vectors, or pretty much like the hypotenuse of a right triangle. So we've got a 45 pounds of force being pulled up and to the right at a 21.8 degree to the northeast direction. So we're looking at magnitude is the length of it, and the direction being 21.8 degrees north of east. Why do we look at that? Well, we start calculating that forces opposite direction to try to create that equilibrium and to be able to break it down into its smaller parts. So this single force right here that we looked at could be broken into two forces. In order to get to this point, I could take a straight line or the hypotenuse of a triangle, but I can also take the x-axis and then go up in the y direction and get to that same point. So there's two different ways, and what we're going to look at in this section is breaking up into these two component red vectors to calculate that green vector itself. So just one more thing to look at the forces. We're looking at if we've got pushing and somebody's pulling a block, altogether that force is 7 pounds. But if somebody's pushing, another one's pushing the opposite direction, altogether there's 3 pounds of force off to that right. So looking back, we're looking at moments, we're looking at forces, and trying to find an equilibrium if we can.